For ring opening polymerization, monomer contain at least one functional group in their cyclic backbone. Otherwise, monomer does not polymerize by ring opening polymerization. Coming on the option number A, given that this structure, you can see in the cyclic structure there is no functional group, so it is not polymerized by ring opening polymerization. Option B. In option B, you can see the one functional group available in their cyclic backbone, so it will be polymerized by ring opening polymerization. Option C, given that you can see there is no functional group in their cyclic backbone, so it will be non polymerized by the ring opening polymerization. Similarly, option D, this is the functional group but not in their cyclic structure, so it will be also not polymerized by ring opening polymerization. So option only B are polymerized by ring opening polymerization due to the presence of these functional group available in their cyclic structure. First, know the melting point is directly proportional to the polar group present in the repeat unit, and melting point is indirectly proportional to the aliphatic chain length in the repeat unit. That means increasing the aliphatic chain length of the polymer, decreasing the melting point, increasing the polar group in the polymer, increasing the melting point. You can see in the option A, B, C, the polyethylene terephthalate have the same polar group. You can see in all options same. So only check the aliphatic chain length. In the polyethylene terephthalate, you can see the aliphatic chain length have the 2 carbon, but in case of the polypropylene terephthalate, aliphatic chain length have the 3 carbon. That means increasing the aliphatic chain length. In the polybutyrene terephthalate have the carbon 4 carbon. So again aliphatic chain length will be increased. In the polyhexylene terephthalate, again the aliphatic chain length have the 6 carbon, increasing the aliphatic chain length. So increasing the aliphatic chain length, melting point will be decreased. So the highest melting point is the polyethylene, then the polypropylene terephthalate, then the polybutyrene terephthalate, then the polyhexylene terephthalate. Minimum pH, then the melting point order, pH greater than, PT greater than, PBT greater than, pH. Ammonia used to prevent the coagulation of the natural rubber latex, while formic acid or acetic acid used to increase the coagulation of the natural rubber. Increase the coagulation of natural rubber. So the option number A correct. Identify the which group have the all the polymer are semicrystalline polymer. Checking option A. In option A, SDP and PP are the semicrystalline, but PS and EF are not a semicrystalline polymer. In option B, PET and PVC are semicrystalline, but PF is also not a semicrystalline polymer, and ABS are an elastomer which is nature in amorphous. Option C, polyamide 6, aniline 6. Aniline 6 is the semicrystalline polymer, but EPDM, SBR, both are the elastomer and amorphous in nature, and PM may also amorphous polymer. Option D, nylon 6,6 या polyamide 6,6, PP, HDPE and PET. These all group are the semi-crystalline polymer. So option D is answer. A polymer blend is developed by mixing up two or more different types of polymer. So option C is correct. Shear rate is the measure of the speed at which the intermediate layer move with respect to each other. So the shear rate is equal to change in the velocity divided by change in distance between the two layers, dx, and its unit is second inverse. So shear rate is equal to dv by dx is equal to relative velocity of layer divided by relative distance between the air. Remember this formula for the shear rate. Option D. Compounding of rubber is done by the two-roll mill. So the correct option is A. I will discuss it detail in the another video. The classification of polymer on the basis of their application. First is the commodity polymer. That means the regular used polymer. This is polyethylene, PP, PVC, polystyrene, PMA, cellulose, plastic, etc. come under the and more come under the commodity polymer. Engineering polymer like the polycarbonate, PET, PBT, lalone, polyoxymethylene, also known as the polyacetal, and more. Polymer come under engineering polymer. This is used in the making of automotive part. Specialty polymer is the very high cost and highest mechanical property, as well as also known for the high flame retardancy polymer. Example: PTFE, polysulfone, PEEK, LCP, liquid crystal polymer, polyamide, polyamide, polyethylamide, and more. Remember this polymer category on the basis of their application. M1 and M2 is the two different types of the monomer, and M1 reacted with the M1 radical and form M1 radical, and M1 radical reacted with the monomer M2 and form monomer 2 radical, and again monomer M2 radical reacted with the monomer 1 and form monomer 1 radical, and again monomer 2 radical is the reacted with the monomer 2 and form monomer 2 radical. Let R1 and R2 is the monomer reactivity ratio. Then first R1 is equal to monomer reactivity ratio, then K1 K12, and R2 monomer reactivity ratio of this reaction, then K22 divided by K21. In question given that R1 tend to 0 only when K1 tend to 0, that means this reaction is not completed. Only this reaction is completed. That means M1 reacted with the M1 radical reacted with the M2 and form M2 radical. And when R2 and when R2 tend to 0, that means K22 tend to 0. That means this reaction is not completed. Only this reaction will be completed. That means M2 radical reacted with the M1 and form M1 reactant. Then you can see first is the M1, then M2, then M1, then M2, then M1, then M2, then M1. You can see all the monomer attached in alternative manner. So when R1 and R2 tend to 0, then form alternate copolymer. Some fabrication process and their product. First is the injection molding. By the help of the injection molding, you made bucket, chair, bottle cap, car parts, helmet, small storage container, and more product. By the extrusion process, we can make the filament, finishing rod, tube, pipe, cable insulation, and more. By blow molding process, we can make water bottle, hollow tube, small chemical storage bottle, and shampoo bottle, and more. By the help of the rotomolding, we make the hollow ball like at the basketball. Basketball is also made by the rotomolding. Storage and feed tank, portable toilet, and more product made by the rotomolding. Toughness of material is defined as absorb maximum energy before breaking. You can understand by the strain stress diagram. This is the stress strain. Then this is the breaking point. Then toughness is defined as the maximum energy absorbed before the breaking. Then this area under the curve is known as toughness. See, then the toughness increases if area under the curve increases. Toughness will be increased if the area under of the curve increases, and area depend upon the elongation of the material and their tensile strength. Then area is increased when the tensile strength of the material increases, and also elongation is high. So after checking the option, we can see in option number C, high tensile strength, high elongation get the high toughness. Blowing agent is used in the making of the polymeric foam to creating the bubble in the polymer. Some example of the blowing agent is the azocarbamide, sodium bicarbonate, CO2, isocyanate plus water, and more. The coloring agent. The coloring agent is used to impart the color in the polymer product. Some example of the coloring agent is iron oxide, zinc ferrate, zinc borate, chromium oxide, and more. The filler. The main use of the filler in the polymeric material to reduce the cost of the polymeric material. First, some example of the filler is called the calcium carbonate, barium sulfate, mica, talc, soapstone, and more. UV stabilizer. UV stabilizer is used to protect the polymeric product from the UV rays. Some example of the UV stabilizer is 2-hydroxybenzophenone, 2-hydroxyphenylbenzotriazole, halls, phenyl salicylate, and triazine, and more. You know that the relationship between the shear stress and shear rate given by neta into shear rate. This equation is valid only for the Newtonian fluid. But for the non-Newtonian fluid, the shear stress is given by A naught into dV by dy power n minus 1 plus b. This term is known as the apparent viscosity given by sigma naught. Coming on the question, in question given that the curve between shear stress and shear rate. You can see in the graph, the slope of the graph continuous decreasing. This is the theta 1, you can see this graph is continuous decreasing. So the slope of curve is equal to apparent viscosity. If slope is decreases, then the viscosity is also, apparent viscosity is also decreases. So in option B is correct. Viscosity decreases with increasing the shear rate. In question you can see increasing the shear rate, the slope of the curve is continuous